All right, hello. Welcome to section 1.2 for Calc survey. Today we're going to be talking about linear functions. Again, more review, but still very important. So just sit back and enjoy. So slope, just a reminder, rise over run. I always told my my little middle schoolers when I taught at Creekside, you have to stand up before you can run. So, and then of course for our purposes, dependent, change in dependent over change in independent. So, and then of course here's your formula, y2 minus y1 over x2 minus x1. So same as all the algebra classes you've done. So it's very important that you begin to think of slope as a rate of change. They're not going to say slope in this course. They're going to call it rate of change. So that's something you're going to have to get very comfortable with. And that's why it's so important that you start to do your homework and you understand how the problems are worded, right? So recognizing data from a linear function, so values of x and y in a table could come from a linear function if, and you guys know this, the differences in y values are constant, but this is really important, for equal differences in x values. You're going to see a lot of tables in this class, and they're going to, and especially IU in your book, they're going to mess with you a little bit, and they might not always necessarily go in the same increments for x. So just be very careful, because it still could be a linear function. It's just if you don't realize that, oh, it went from 0 to 2, then 3 to 6, you got to be a little careful. So, but for now, we'll keep it very basic. So determine which of the following tables could represent linear functions. So you want to come here. Always check your x's. They're increasing by increments of 3, so we're good to go. And then look at your y's. Take the one to the right and then subtract the one to the left. You get 5. Now see, do you add 5 to the next one? Yeah. Add 5, add 5. So since it has a common difference is what we called that, yes, this is a linear function. Now, for the next one, check your x's, going up by 1s each time, we're good to go. Now look at your y's. You increase by 2, but then, you increase by 4, and you increase by 8. Now there's a really nice pattern, but it's not linear. It needs to be the same number you're adding or subtracting each time. Okay, now, example 2, finding equations from data. You need to be very, very comfortable with switching your independent and dependent. So notice you are so used to getting a table with your x values on top and your y values in the bottom row. Well, okay, well, it's not always going to be like that. So that's why I showed you down here. Find b as a linear function of a. And remember in the last section we talked about what follows the word of is going to be your independent variable 99% of the time. So that's your independent. So notice I wrote over here the actual ordered pair with a comma b. And then when I switch it, find a as a linear function of b, I wrote b is my independent, a is my dependent. So when you go to do this, then I would highly suggest don't work from the table. Pull 2 ordered pairs, write them down, and then go from those 2 ordered pairs. Same thing over here. Pick 2 ordered pairs, make sure you switch, and write them down and go from there. Now, also notice over here off to the right, I wrote y equals mx plus b. That's your slope-intercept form. Then I also wrote, can't see the parenthesis there, but I also wrote point-slope form. That's a bridge way to get to either slope-intercept or what you called standard form back in algebra and algebra 2. So this is going to be a very nice, you should have used that a lot in pre-calc. So y minus y1 equals m times x minus x1, and that's what I used here. And then I went ahead and solved, I added over the distributed, added over the 1 to get it in slope-intercept form. But if it doesn't indicate how you have to leave your equation, shoot, just leave it in point-slope form. So slope-intercept, point-slope form, standard form, okay? But just be very comfortable and watch out for if it's specific on what needs to be made the independent and dependent, and don't get too set on the top always being your independent. So just be careful with that. All right, so here are some examples. A cell phone company charges a monthly fee of $25 plus 5 cents per minute. Find a formula for the monthly charge C in dollars as a function of the number of minutes M the phone is used during the month. Guys, this is a problem you've been doing since pre-algebra. So don't overthink it. That's that's easy to do in this class. Do not overthink these problems. So you have your fixed cost. Remember, that's what we called this 25 here. So that's your fixed cost plus, and then any additional time added on to that. But you have to multiply that by 0.05. That's your slope. Notice it's per minute, dollars per minute. And that's how we're going to do that. Now you can change these variables around, but make your life easy. Use the variables that it references. Oh, and it did specify here, so I guess we have to. If it does specify in the problem, you need to use those variables. Okay. And guys, I know I'm going through this video and I'm talking fast, but just email me if you have questions. Take a note throughout the notes and say, Cogswell, I didn't understand what you said while you were talking through example 1, and email me, right? So, excuse me. In problem 2, all right, in a California town, the monthly charge for waste collection is $8 for 32 gallons of waste and $12.32 for 68 gallons of waste. All right, now that to me just screams 2 ordered pairs. But before you go to write down your ordered pairs, I would highly suggest reading through the problem. It says, find a linear function for the cost of waste as a function of the number of gallons. As a function of the number of gallons means that's what needs to be your independent variable. So notice that's not the order I wrote this down for you. So you actually want to make 32 your x and 8 your y. So be careful on that. Did I do that on purpose? Yes, I want to make sure you're paying attention to what the problem specifies as your independent and dependent. Okay, so now that I have my 2 ordered pairs, find the slope. You guys can do that. y2 minus y1 over x2 minus x1. That's where that 0.12 is coming from. And then you've got your ordered pair. Use either ordered pair, doesn't matter. So I just use the first one because it's nicer. So y minus, now I probably shouldn't have used y, use c right there, but I wrote what I was used to. So y minus 8 equals 0.12 times x minus 32. And then notice that when it did say find a linear function formula for the cost. I interpret that as you need c equals, so it's probably slope-intercept form. So I went ahead and distributed the 0.12, added over the 8, and notice I wrote it in the terms of the variables that it requested. Okay, then what is the slope of the line found in part A? That's that 0.12, but then notice it says give units and interpret your answer in terms of the cost of waste collection. So whenever you see that interpret, that means I want units. Use units to explain what's going on. So there's your $0.12 per gallon. And anytime it's slope, it needs to be a rate, so per gallon. All right, and then finally, what is the vertical intercept of the line found in part A? Give units and interpret your answer. Okay, so to get the vertical intercept, remember you plug in 0 for your independent variable, so this goes away. So that's where that 4.16 is coming from, and that's going to be that's in terms of dollars. Notice that's your C, that's your cost, and that's your flat monthly fee. Okay. All right, and I think that's it. Email me if you have any questions.